The evolution of artificial intelligence. How AI was created. Artificial intelligence, AI, is one of the most transformative technologies in modern history, shaping industries, research, and our everyday lives. To understand how AI was created, we need to explore its conceptual roots, technological advancements, and key milestones. AI emerged from a confluence of disciplines like mathematics, computer science, philosophy, neuroscience, and linguistics. Here's a comprehensive look at how AI was born and how it evolved. The early conceptual foundations. AI's genesis can be traced to the ancient pursuit of understanding intelligence and cognition. Philosophers and mathematicians laid the groundwork for many of the ideas that would later become central to AI. 1. Philosophical beginnings. Ancient thinkers like Aristotle explored logic and reasoning, leading to the development of formal logic systems. 1. These ideas set the stage for creating machines capable of thinking. 2. Mathematical foundations. In the 19th century, George Boole developed Boolean algebra, a system of logic that later became integral to computer science. 2. Similarly, Alan Turing's work in the 20th century introduced the concept of a universal machine, capable of performing computations. Turing's 1950 paper, Computing Machinery and Intelligence, asked the question, "Can machines think?" and proposed the Turing test as a benchmark for machine intelligence. The birth of AI as a field. The term artificial intelligence was officially coined in 1956 at the Dartmouth Conference, where scientists like John McCarthy, Marvin Minsky, Nathaniel Rochester, and Claude Shannon gathered to explore the possibility of creating machines that could simulate human intelligence. Key developments during this period included: 1. The logic theorist, 1955. Developed by Alan Newell and Herbert A. Simon, this program could prove mathematical theorems and is considered one of the first AI programs. 2. Early optimism. Researchers believed that replicating human intelligence in machines was a matter of programming the right rules and logic. The rise of early AI systems. The 1960s and 70s saw the creation of systems that could mimic specific human behaviors, although they were limited in scope. 1. Expert systems. These programs could make decisions in narrow domains by applying a set of predefined rules. 1. Examples include DENDRAL for chemical analysis and MYCIN for medical diagnosis. 2. Natural language processing (NLP). Early programs like ELIZA, created by Joseph Weizenbaum in the 1960s, simulated conversation by mimicking human-like responses, albeit in a rudimentary way. Despite these advancements, AI faced significant challenges, such as limited computational power and the inability to generalize knowledge. The AI winter. By the 1970s and 80s, enthusiasm for AI waned. Researchers overpromised results, and the lack of tangible breakthroughs led to reduced funding and skepticism, a period known as the AI winter. Key reasons for this stagnation included: 1. Hardware limitations. Computers lacked the power needed to process complex algorithms efficiently. 2. The complexity of intelligence. Real-world problems, like understanding language or vision, were much harder to solve than anticipated. However, AI research continued quietly in the background, and some breakthroughs during this time would prove crucial in the future. The Renaissance. Machine learning and neural networks. The 1980s and 90s brought a resurgence in AI, driven by advancements in machine learning (ML) and neural networks. 1. Neural networks. Inspired by the human brain, neural networks use interconnected nodes to process information. 1. Although initially sidelined, improvements like backpropagation, an algorithm for training neural networks, revitalized interest in this area. 2. Data and algorithms. Researchers shifted focus from hard-coded rules to algorithms that could learn patterns from data. 2. This approach allowed machines to teach themselves, rather than rely solely on predefined instructions. These developments mark the transition from symbolic AI to data-driven AI. The era of big data and deep learning, the early 2000s, saw explosive growth in data availability and computational power, enabling AI to tackle more complex problems. 1. Big data. The rise of the Internet, social media, and sensors generated massive amounts of data, providing a rich resource for training AI systems. 2. Deep learning. Building on neural network research, deep learning emerged as a technique to process large datasets. 2. Algorithms like convolutional neural networks, CNNs, revolutionized image recognition, while recurrent neural networks, RNNs, advanced language processing. Key breakthroughs during this era included: 1. Speech recognition. Google and Apple integrated AI into products like Google Assistant and Siri. 2. Image recognition. AI began outperforming humans in recognizing objects in images. Modern AI and its applications today. AI spans diverse fields, from healthcare to finance to entertainment. The creation of large-scale AI models, such as GPT, Generative Pre-trained Transformer, by OpenAI, demonstrates the power of modern AI systems. 1. Natural language processing. Advanced models like GPT-4 can generate human-like text, perform translations, and even write code. 2. Autonomous systems. AI powers self-driving cars, drones, and robotics. 3. Healthcare. AI assists in diagnosing diseases, personalizing treatment, and accelerating drug discovery. These advancements are driven by powerful computing, e.g., GPUs, sophisticated algorithms, and global collaboration. The ethical and future challenges of AI. As AI becomes more integrated into society, its creation raises ethical concerns and challenges. 1. Bias and fairness. AI systems trained on biased data can produce discriminatory outcomes. 2. Privacy. Large-scale data collection for training AI models raises concerns about user privacy. 3. Job displacement. Automation may disrupt industries, necessitating policies to address economic inequality. Looking ahead, researchers are focusing on explainable AI, XAI, AI alignment, ensuring AI acts in human interests, and artificial general intelligence, AGI, systems that can perform any intellectual task a human can do. AI's creation was not a single moment but an ongoing journey fueled by interdisciplinary collaboration and iterative progress. From philosophical musings to cutting-edge neural networks, AI continues to evolve, reshaping the way we live, work, and interact with technology. Its story is far from over, as researchers and society grapple with its possibilities and challenges in the years to come.